All right, let's take care of this new question here where the question sentence begins with, if you drink 2/5 of a liter, how much water remains? So what I want you to focus on first is not the number that we see in the question sentence. We really want to focus right here on how much water remains, particularly the word remains. Everybody, when we think about that word remains, through experience, what does remains typically hint at us doing? Yeah, subtraction. Because remember, subtraction is the operation that helps us determine a gap, how much is left in between. And so when we think about the situation here, it says a bottle contains 3/4 of a liter of water. If you drink 2/5 of a liter, how much water remains? So even if you're a little intimidated by fractions, we can absolutely still center ourselves around this, because if you think about this not in terms of fractions, let me go ahead and just, etch that out and etch this out over here. If we thought about this as whole numbers and we said, hey, a bottle contains 2 liters of water. If we drink 1 liter, how much is left? I know most of us would be sitting here saying, oh yeah, I'm thinking about that in real life. If I have 2 liters, I drink 1 liter, subtract 1, and I'm done. And that's the same principle here. Even though it's fractions, it's the same idea. Take the water that we had in the beginning, subtract what we ended up drinking, and that is going to give us our final answer. Now, the only question is, how do we subtract these two fractions? And this is what we always want to think of. Whenever we're adding or subtracting fractions, my party people, anytime we're adding or subtracting, we must have the same denominator. So in this case, we first ask, can 4 go into 5? Not quite. Then we want to ask, hey, what's the smallest number that both 4 and 5 can multiply up to? And what would that number be, everybody? What is the number that 4 and 5 can both multiply up to? If you said 20, absolutely correct. We always want to start off with the bigger number, and we can go ahead and go 5, then 10. 4 doesn't go into 10. 15, 4 doesn't go into 15. 20, 4 does go into 20. So that's how we know that 20 is going to be the denominator I'm going to use for both of these fractions. Now, up first, what do I multiply 4 by to get 20? That's going to be 5. 4 times 5, that's 20. I think we can all wrap our heads around that. So we're going to multiply by 5 in the denominator. And that numerator, 3 times 5, gives us 15. So we have that first part all sorted up. And then up next, we're going to ask ourselves, 5 multiplied by what gives us 20? And coincidentally enough, that's going to be 4. So we'll take the 4, multiply it in the denominator and in that numerator. And so we have 2 multiplied by 4, and that gives us 8. 20 is expected. That's what we wanted. So we're good. So the last step here is just going to be to subtract. And from there, we'll keep the same denominator. Everybody, what is 15 minus 8? What's that going to give us? Yeah, that'll be 7, because 8 plus 7 is 15. So there we are. We have 7 over 20. And that is how much water remains. Again, one more time before we continue. We picked 20 as the denominator because that is the smallest number that both of these denominators can go into. This is the concept, again, of finding the least common denominator. All right, my party people. So there it is. Right there. Least common denominator. That's the idea we just exercised to get this setup done. All right, next question. Let's read the question sentence first, and then from there, we'll see what we can do. So here it says, what is the length? Okay, everybody, can you confirm? Can you confirm that what we're asking for in this question is the length? Not area, not perimeter, but actually the length. All right, that's going to be very important to note down, because as we go through the information that we have, we see that it says a rectangular floor has an area of 96 square feet and a width of 8 feet. What's the length? So I know that everybody here saw the word area. Now, the problem is most of us might freak out a little bit and think that we're going to do 96 times 8 to get the area, but that's not the case. Remember that we're looking for the length, and so when you're given the area, let's write this down. When you're given the area for a rectangle particularly, again, length times width for a rectangle in particular, notice that when we plug in the information that we have, look at what happens. When we plug in, look, this is all you have to worry about. Plug in the information that you have. Area 96. So 96 right here. And then we're going to plug in that width of 8. So I'll plug in 8 right there and I'll put an L. When you plug in the information to the right places, everybody, it becomes more clear what you need to do. Everybody, are we working forward to find the area, or are we working backwards to find one of the pieces? Yeah, we're working backwards. Absolutely working backwards. And so we have to think about opposite operations. Here we have length times 8. Everybody, to undo, to work backwards and get rid of multiplication by 8, we're going to do the opposite, and we're going to divide both sides by 8. Just like that. And once we do that, we will cancel out on the right. And then if you've practiced your multiplication tables, you may know that 96 divided by 8 will be 12. Because 8 times 12 is 96. And so the correct answer to this problem here will be answer choice D, 12 feet. Again, we get that 12 feet because we plugged in the area because it was already given, and we actually had to work backwards to find that length. So again, that's why we didn't multiply. That's why we divided, because we already had the area and wanted to find the length. So it's a good little bit of practice. And if you're not feeling too confident right now, keep trying, because I promise you the concept of working forward and backwards, it appears in every single concept, and we have to get used to it. And you will. Just give it time. All right, next up, what we're going to do here is evaluate an expression. And so to evaluate this expression, we see that we have b equals 5 that we'll replace into every instance that we see. So that's the first thing I'll take care of. Just making sure I replace things properly. So we have 3.2 multiplied by 5. And then we add 0.9 to that. And we subtract 1.5 multiplied by 5. All right. So from here, let's go ahead and take care of things. So immediately I noticed that we have 3.2 times 5. So let's just handle that. 3.2 times 5. And when we multiply by decimals, remember, just ignore the decimal, bring it back at the end. So here, 2 times 5 is 10, carry the 1. 3 times 5 is 15, carry the 1 is 16. So there we go, we have 160 with 1 decimal place being brought back, so that makes it 16. Next up, we add 0.9, and then we subtract whatever 1.5 times 5 is. So we have 1.5 times 5. And if you know that 15 times 5 is 75, then you know that this will be 7.5. So here we go. 5 times 5 is 25. Carry the 2. Then we have 1 times 5 is 5. Carry the 2 is 7. Bring that 1 decimal place back right over there, just like that. And we have 7.5. So there we are. We have everything laid out. And so we just bring the 16 and 0.9 together. So that's 16.9. Then we subtract 7.5. And we can do that right over here. 16.9 minus 7.5 with those decimal places lined up. Next, we'll do 9 minus 5, which is 4. 6 minus 7, can't do that. But we can just do 16 minus 7, and that will be 9. And there we are. Our correct answer here is 9.4, which is answer choice B, 9.4.